How can circuit simulation software model extreme environmental conditions? Imagine designing a circuit that needs to work perfectly in the freezing cold or scorching heat. How do engineers make sure it will hold up? That's where circuit simulation software comes into play. These tools help predict how electronic components behave under tough conditions without building real prototypes. They do this by including detailed physical and electrical data that reflected real-world stresses. To simulate extreme environments, the software goes beyond just electrical signals. It adds models for temperature changes, mechanical shocks, humidity, and even radiation. For example, if you want to see how a circuit performs in high heat, the software uses temperature-dependent device models. These models change how components like transistors and resistors behave as temperatures rise or fall. This helps engineers see if parts might fail or degrade in cold or hot conditions. Another key feature is electro-thermal coupling. This means the software solves electrical and thermal equations at the same time. It calculates how power dissipation heats up components and how that heat affects electrical performance. For instance, in power electronics, this helps optimize cooling systems and prevent overheating. Some simulation tools also include libraries based on manufacturer datasheets or real testing data. These models can account for effects like humidity, radiation, or aging. So, if a circuit is meant for space or military use, engineers can test how it will hold up against radiation or moisture. Multi-domain simulation is another advanced feature. It combines electrical, thermal, and mechanical models into one simulation. This allows engineers to see how vibrations or shocks impact circuit reliability. For example, automotive wiring harnesses can be tested for mechanical stress and temperature swings all at once. Simulators also allow for fault analysis. Engineers can model scenarios like overvoltage, short circuits, or component failures caused by environmental stress. This helps identify weak points before physical testing. Using these tools in practical projects saves time and money. Aerospace engineers, for example, use electro-thermal simulations to ensure circuits work in extreme temperature swings and radiation. Automotive engineers test wiring under thermal and mechanical stress to prevent failures. Power electronics designers analyze how semiconductors perform under high current and heat to improve cooling and reliability. Cloud-based simulation platforms make this process even faster. They let engineers create models, run complex tests remotely, and collaborate easily. Compatibility with SPICE and VHDLM's models supports mixed-signal and multi-domain simulations, which are essential for modern electronics exposed to harsh environments. In short, circuit simulation software models extreme environmental conditions by combining detailed physics, multi-domain analysis, and real-world data. This helps engineers design systems that are reliable and ready for the toughest conditions.